In these videos, we will talk about inclined planes and the motions that affect objects on them. Our first example, a 10 kilogram block sits on an inclined plane at 15 degrees. What is the force of static friction and what is the normal force? We can always draw a real-life diagram with our object on an inclined plane, but for best use, we need to draw a free body diagram. The force of gravity is acting downwards, straight down. Force of static friction is acting up the hill, because if it wasn't there, the block would start sliding down the hill. And normal force is always perpendicular to the surface, so it acts up towards the left. We can break down the force of gravity further into the Fg perpendicular component, as well as the Fg horizontal or Fg parallel component. The first thing we need to do as well is to list our variables. So we have a 10 kilogram block and an inclined plane of 15 degrees. The first thing we need to find is the force of static friction. And because the force of static friction is acting in a parallel direction, let's look at the parallel direction. Our net force equation for the parallel direction is the force of static friction plus the force of gravity in the parallel component. F net we can always substitute with ma equals force of static friction, and Fg parallel we can replace with mg sine theta. And remember, because now we're substituting, we should check for signs. Fg parallel is acting downhill, so it is negative using our convention system, so we put in our negative sign. Also, another thing that we can do right now is say that acceleration is 0 because the block is at rest. So then we can now solve for FFS. So the force of static friction is mg sine theta, which is equal to 10 kilograms times 9.81 meter per second squared times the sine of 15 degrees. So our force of static friction is 25 newtons. The second part of the example asks us to find the normal force. And because normal force is acting in the perpendicular direction, let's look at the perpendicular direction. First thing we do is set the F net equation. What are the forces that are acting in the perpendicular direction? It is the normal force plus Fg perpendicular. We substitute F net with ma, and Fn remains Fn, and Fg perpendicular we can now substitute with mg cos theta. Because we're substituting, let's check for signs. Fg perpendicular is acting down, so therefore this should be negative. As well, the block is not accelerating in the perpendicular direction, thus that is 0. So then Fn is mg cos theta, which is 10 kilograms times 9.81 meters per second squared times the cos of 15 degrees. All of that is equals to 95 newtons. Now let's look at an example where the block is accelerating down. A 2 kilogram block slides down an inclined plane of 10 degrees and encounters a force of friction of 2 newtons. What is the block's acceleration? So here with our real-life diagram, we can draw our free body diagram. The force of gravity is acting straight down. Kinetic friction in this case is also acting uphill because the block is sliding down, and friction is acting in the opposite direction of motion. And normal force is acting straight up to the left at 90 degrees to the surface. And we're told that our block is 2 kilograms. And the force of kinetic friction is 2 newtons. And we're asked to find the acceleration of the block. We know the block is accelerating downhill, and downhill is in a parallel direction. So let's look at the parallel direction first. Our net force equation, once again, in the parallel direction is Fg parallel plus the force of kinetic friction. We can replace F net with ma. Mg parallel we can replace with mg sine theta. Because the force of gravity in the parallel direction is acting downhill, this is going to be negative. And the force of kinetic friction, we are told, is 2 newtons. However, the force of kinetic friction is acting uphill, therefore this is going to be positive. In this case, we cannot make ma equals to 0 because the block is accelerating. In fact, we are solving for acceleration. Okay, let's do some substitutions. The mass, we were told, is 2 kilograms times acceleration equals negative 2 kilograms times 9.81 meters per second squared times the sine of 10 degrees plus 2 newtons. We do our math and solve for A, and we find that acceleration is 0.70 meters per second squared. Notice in this case, we do not need to look at the perpendicular direction, not relevant, because we are given all the facts in the parallel direction and we can solve for acceleration using just those facts. However, if we're not told the force of friction, we may have to look at the perpendicular direction to find the normal force and to solve for the force of friction in that manner, which is what we'll do in the next example. Let's now look at a more complex example. A 25 kilogram block accelerates down an inclined plane of 15 degrees at 0.5 meters per second squared. What is the force of kinetic friction and what is the coefficient of kinetic friction? Let's skip the real life diagram and go straight to the free body diagram. The force of gravity is acting straight down. The force of kinetic friction is acting uphill, and normal force is acting at a perpendicular direction to the plane. Force of gravity we can break down into Fg perpendicular as well as Fg parallel. We're also told the mass of the block is 25 kilograms. Inclined plane is 15 degrees. Acceleration is 0.50 meters per second squared. And we're asked to find the force of kinetic friction first. Okay? Because the force of kinetic friction is acting in the parallel direction, let's first look at the parallel direction. Our net force equation in this case is Fg parallel plus coefficient of or force of friction in the parallel direction. Okay, we can replace Fnet with Ma. Fg parallel we can replace with mg sine theta. Because Fg parallel is acting downhill, this is actually negative. And f of fk we don't know. In fact, that's what we're looking for. Further substitution, 25 kilograms for mass. Acceleration is 0.50 meters per second squared. We're substituting numbers again, so let's check the signs. Acceleration, we're told, is accelerating down, so therefore this should be negative as well. Continuing with our substitution, equals mass, 25 kilograms, times 9.81 meters per second squared, times the sine of 15 degrees, plus f of fk. And I forgot to carry over the negative sign right here. We solve for our math. F of fk equals 50.97 newtons, or 51 newtons uphill. The second part of the question asks us, what is the coefficient of kinetic friction? In order to find the coefficient of kinetic friction, we need to look at the formula Ff equals mu Fn. We're looking for mu, but we don't have Fn. Therefore, we should look in the perpendicular direction to find Fn. So Fnet equals Fn plus Fg perpendicular. Fnet we can replace with Ma. Fn is what they're looking for. Fg perpendicular we can replace with mg cos theta. Let's check the signs. Fg cos theta, Fg parallel, or Fg perpendicular, sorry, is acting down, so therefore this should be negative. As well, the block is not accelerating in the perpendicular direction, so this is 0. Solving for Fn, Fn is positive mg cos theta. Substitute 25 kilograms times 9.81 meters per second squared times the cosine of 15. We find that our normal force is 236.9 newtons. Now lastly, we can finally find the coefficient of friction. Solving for the coefficient of friction, mu equals Ff divided by Fn equals 50.97 newtons divided by 236.9 newtons, and that is equal to 0.22. For our last example, we'll do a more complex example. A 10 kilogram oak block sits on a 10 degrees inclined plane. The coefficient of kinetic friction is 0.3. What force do you have to pull in order to accelerate up the incline at 0.5 meters per second squared? Let's go straight for the free body diagram. We have the force of gravity acting down, and we're pulling it up. Therefore, here we have an applied force. It's a force we haven't dealt with before on inclined planes, but you just have to read the question in order to determine which way you have to draw the free body diagram. Remember, this block is accelerating up the incline. Opposing that motion is the force of kinetic friction, and this is going to act downhill because it opposes the upward movement. And lastly, we have the normal force as usual. We have to find the applied force. So our mass is 10 kilograms. Our angle is 10 degrees. Our coefficient of friction is 0.3. And we're looking for the applied force. Now, as the applied force, you can see clearly it's acting in the parallel direction. So let's first look at the parallel direction. Our net forces in the parallel direction is the applied force plus the force of kinetic friction plus the force of gravity in the parallel direction. We can replace F net with ma, the applied force. The force of kinetic friction, we don't know actually. So let's just leave it as a blank right now. And the force of gravity in the parallel direction is mg sine theta. Remember, now we're substituting mg sine theta. The force of gravity in the parallel direction is actually negative because it's going downhill. Okay. We have a mass, and we have an acceleration. We want to find F-app, but we don't have F of Fk. We don't have the force of kinetic friction. Well, how can we find the force of kinetic friction? Well, let's look at the equation. Ff equals mu Fn. Right? We need to find Ff, and we're given mu, but we don't have Fn either. How can we find that? Oh, Fn is in the perpendicular direction, so let's look at the perpendicular net force equation. F net equals Fn plus Fg perpendicular. Replace F net with ma. Fn is still Fn. Mg or Fg perpendicular we can substitute with mg cos theta. We're substituting, so let's check for signs. Fg perpendicular is acting down or negative in our direction. So technically, this should be negative. As well, the block is not accelerating in the perpendicular direction, so ma equals 0. Rearranging for Fn, Fn equals mg cos theta, which is equal to 10 kilograms times 9.81 meters per second squared times the cosine of 10. Fn equals 96.6 newtons. Now we can use this number to find our Ff. Ff is mu, which we said is 0.30 times Fn, 96.6 newtons. So the force of friction is 29 newtons. Now can we go back to our parallel equation and substitute that number in? We can also substitute in the mass. We said it was 10 kilograms. Acceleration is 0.50 meters per second squared. Let's check the sign. We're told it's going to accelerate up. So therefore this is positive 0.50 meters per second squared equals F plus the force of friction we just determined to be 29 newtons. Again, we're substituting, so let's check for signs. The force of kinetic friction is acting downhill, therefore this is technically negative, plus negative 10 kilograms times 9.81 times the sine of 10 degrees. Solving for FAP is 51 newtons. And that is our final answer. This question is a little bit more complex, a little bit more involved. We need to look at both the parallel and the perpendicular direction. But if you don't have enough information to solve for everything in the parallel direction, always look for the information in the perpendicular direction.